This lesson is our first look at graphics animation. It's a very simple look. All that happens is a black circle moves from left to right across the window. In fact, this animation technique is a little too simple and has a problem that we're going to have to clear up later. But the point is here to show you the fundamental structure of all animation. This is the simple animation class that's a frame used to display a simple canvas component, just as we've done a number of times before. In this case, the component being displayed is called flicker. The reason it's called that will be made apparent at the end of the lesson. This is the flicker class, which is a canvas component. These are the values of the height and width of the window and the X and Y starting position of the circle. The window is wider than it is tall, and the circle is sized to exactly fit the window vertically, and it will slowly move across the window from left to right. The diameter of the circle is the same as the height of the window. The horizontal starting position is one full width of the circle off to the left. The animation actually makes its appearance off stage to your left and slowly crosses the window and drifts off stage right. By the way, it's perfectly okay to draw graphic objects outside of the window. Java just throws it away. Lots of times it's easier just to draw images out there than try to figure out where the edges are. Java just throws it away anyway. The technical term for that is clipping, and Java has a special algorithm for taking care of it. And the guys that wrote that algorithm are better than I am at clipping, so I just let them handle it. Here is the thread declaration. I call it looper because that's what it does in the run method. By the way, I don't know if I mentioned this before, but it is worth mentioning again. The runnable interface and the thread class are both in the Java Lang package. This is the same package as the string class and doesn't need to be specified on an import statement. All the members of the Java Lang package are like parts of the language. The constructor of the flicker class sets the size of the canvas window, creates a thread object, and starts it running. All that's left in this program are the run method to manage the animation and the paint method to draw the pictures on the screen. All the code in the run method is inside a try block. It doesn't all have to be inside the block. The only thing that requires it is the sleep method, but I find it easier to put the whole thing in there. The purpose of the run method is to execute the code in this infinite loop. It is executed once for each frame of the animation. The sleep method is used to determine the length of time between frames. It needs to be fast enough so the frames run smoothly instead of jerky, so I chose a 33 millisecond delay. This is close to 30 frames a second. Television pictures run at 30 frames a second and they don't flicker. Movies actually run at 24 frames a second, so we could have actually lengthened the delay and run things a bit slower. But 30 frames works just fine. If you get it too fast, your graphics routine will eat up the CPU time and your whole computer will get sluggish because the other programs are being starved for CPU. Notice how the value of x is adjusted inside the if statement. Every time through the loop, x is incremented, causing the position of the circle to be 1 pixel to the right of its previous position. However, if the value of x has reached the right side of the window, that means the circle has disappeared off stage right, and we need to move it back so it'll start over. Now this method is a trick you haven't seen before. Up until now, we let Java decide when it needed to call the paint method. We can't just call the paint method directly from inside the program because we don't have the graphics object to pass to it. So we do the next best thing. We tell Java that it's time to call the paint method. A call to repaint schedules a call to paint. You could actually call repaint as many times as you want because all it does is run back in the back and shout call paint. As soon as Java has the opportunity, it calls the paint method and then forgets how many times repaint shouted at it. This paint method is a little bit different because here we have a small problem we need to solve. When this method is called to draw the circle that was drawn before is still on display. That means we have to wipe out the display before drawing the next frame. To do this, we draw a rectangle the size of the window using whatever color we would like for the background. Another way to do this would have been to set the background color in the constructor and then call the method clearRect to paint the window with that color. But the result is the same either way. As you get to know Java better, you will discover there is always more than one way to do anything. Anyway, once the entire window is set to a convenient background color, we set the current color to the color of the circle. We fill the circle at the current position specified by X and Y. Now, here's what the program looks like. And there it goes. The circle slides slowly across the window. There is one problem, but you can't see it. The way this screen is being recorded and played back for you, the flicker that's appearing is automatically being suppressed. But you should compile this program for yourself, and you'll see what I mean. The flicker will be more predominant on some systems than on others, and it'll look different on different systems, but it will always flicker. What happens is the screen occasionally is updated after it's cleared, but before the new circle is drawn. So you get momentary flashes of white peeking through the black circle. Compile the program and run it for yourself, and you'll see what I mean. The next lesson is about fixing this flicker problem.